Of the Dash community call. Today we have Mircea from Keysight, and he's going to give us a talk about some improvements he's made on the Keysight end of things. If you want to go ahead, Mircea.
Sure. Let me know if you can see my screen. And if the font is too small, just let me know. I'll increase it. If not, I'll keep it like this. So today I want to talk about two PRs that we have done recently. One is for a Dash, let's call it pseudo config generator, and an update to the hero test is not yet the full hero test, and I will explain why we call it baby hero test and the scale and how we're gonna get it to the full hero test. So first, with a Dash config generator that is needed in order to generate the config that is needed for the test. So basically, both of them go hand in hand. Now the generator, I placed it under test in confgen directory. And right now this config, it's based on the Dash reference config example. This is not the final form. So this generator will keep morphing as the Dash config gets finalized. So as we get more updates there, I'll update this one here. Also in parallel, let's say I will copy paste this one and transform it into like site generator, site generator, gRPC generator, whatever ways are there to program the DPU, I can make a generator for it, keeping the same logic, but different APIs or ways of configuring it. So I'll change the way of configuring, but keep the logic the same. At this moment, it's just exporting everything in a JSON file based on this format. Few things which are important here. I gave here a few variables, and I'll talk about it. In the test, we have a variable file that this kind of drives the scale of the config that is generated. I gave an example for two scales, one that is a reduced config and one that is the full working config. And by changing two values in here, it will generate the medium size or the large size config. Now, regarding the scale, so how the scale is calculated, and then I'll go into the IPs and everything else. But scale-wise, let me put this on half of the screen and on this other half. Oh, perfect. So these are the test requirements here, and we have okay, one more. Okay. Basically, ENI is very self-explanatory. This will be the ENI count variable from the variables file. Number of NSGs, they talk about 6 here in the test. There are other mentions of 10 basically. So this can be changed, but it's basically ENI count multiplied by 2 because of the direction, inbound, outbound, plus ACL table count, which is right now set to 3. Like I said, there is a mention to 5, so it could be, I don't know, 10 plus ENI counts of 80. ACL rules, it's basically the NSGs, plus there is a requirement to have 1,000 rules per NSG, and this is controlled by ACL rules per NSG variable. Prefixes is nothing else but ACLs and how many IPs we can have, prefixes we can have in each ACL rule. Mapping table, I have another variable for how many IPs from each ACL rule we want to be mapped. Just to keep the 2 million count, you don't want all of them. So let's say here you need 200 prefixes, but here maybe you just want to map 40 of them to make 2 million mapping. Now, based on some other documentation here from Dash, there is a requirement for mapping table to go up to 10 million. So in the end, there is nothing that stops you to go in here and just leave this, 9.6 million prefixes, 9.6 million IP mapped. Could be valid as well. And routes, And I'll explain. This is a bit longer, and this does not quite respect the number that is specified here. In order to try to make it not summarizable, basically I take them like groups, let's say of 8 IPs, and then I make out of 8 IPs 3 routes. So basically it's divided by 8 multiplied by 3, and you get, I think, 3 point something million routes. Or you can make it a group of 16, it needs to be a power of 2, and you have 16 IPs, you divide by 16, but then you have 4 routes for these 16 IPs, I believe, and you get another number which is not 1.6, is lower. So route is not quite there, but again, based on the dash scale requirements, if you are to have 64 ENI each with a 100K routes, this is basically 6 million routes. So we are well within, even if we do 3 million routes. So it shouldn't be a problem. Now let's go and see how this is all done. Basically, the logic trying, and here I need a lot of feedback because you guys know how the hardware works better. Trying not to make anything summarizable or okay, I don't know what's happening. Can you still hear me?
Yep.
My image disappeared. Okay, sorry for that. The nice Windows 11 crash. I don't know what happened. Let me bring back everything on screen. Is my screen still visible?
Yes.
Yeah, we see it now.
Yes,
okay,
we see.
okay, perfect. Okay. So in the config, we have the ENI. Each ENI has 3 tables for inbound, 3 tables for outbound. Like I said, some documentation says it needs to be 5. ID usually IDs throughout the config. If you see it starting with 1, that's ENI 1. If it starts with 7, that will be usually ENI 7. And this last number, it's usually the table ID, 1 to 6. And we have the ENI, so we have all the 8 ENIs in here. When it comes to ACLs, what we have a group of 512 IPs, and you have to think that one is distributed to a deny, and one alternatively is distributed to an allow, and so on. So if we see here, we have 1.128.0.1/32. This is in the allow rule with priority 1, and 1.128.0.2/32, it is in priority 2 action deny, and so on. And this goes like this. You have, like I said, a group of 512 IPs that you can consider for an allow and the deny combo. And then you can have 256 in allow, up to 256 in deny. And we just need 200 in order to achieve the scale. And having them like this, odd even, in allow deny, I hope the hardware cannot do any tricks and basically aggregate all this and say, hey, this big bunch, it's all allow, everything is deny, and summarize, and so on. So this is the idea behind the ACLs. And then to the next group, it just increments by 2 here. So this gives us the 512 IP, and it's another group of 512 IPs that is distributed odd even between allow deny. And it keep going like this 1,000 times for all the ACL rules. Now, when it comes to mapping, it just takes the first X IPs from each ACL rule and it creates a map for it. This is nothing here. It just adds a MAC and an IP and the remote VTEP IP. Okay, now let's go to routes. So routes, in order to try not to be able to summarize them, what it does, for example, in this case, it takes a group of 4 IPs. And if you have a group of 4 IPs from each group of prefixes, we take the first 2 IPs and we put a route for them. So this will be, let's say, 2.128.0.0/31. So this will account for 2 IPs. Then we have 2.128.0.2/32. That coincides actually with the deny rule, which is not present here, so it's skipped. And then we have a route 2.128.0.2/32, which it's for the allow rule. And then again, we have a route for the next group for 2 IPs, 1 IP from the deny, we skip it. And then again, another IP has a route. So having these gaps in the routes, I hope they cannot be summarized by the hardware. So yeah, so this is with a group of 4 done. With a group of 8, basically we'll have a route with 30 for 4 IPs and a route with 31 for 2 IPs. So that will make 6. 1 IP will be skipped. And then you have another route with a /32. So you'll have 7 IPs out of a group of 8 having routes and 1 being skipped. That skip, like I said, coincides with a deny rule. And this is how the routes are. I don't know, questions so far?
You might want to increase the font and zoom in a little.
Yeah, just, oh, okay.
Yep. I have just one question while Demar is speaking. So
Yeah.
this file has been generated automatically, I suppose, right? So it's 10,000
Yes.
lines.
Yeah, so.
What was the use as a base for this?
Yeah, okay. So, oh, okay. Let's, let me zoom back to some normal level. Okay. So, if we have here, okay, it's not in my repo. We have the dash reference config example. So this was the base for the JSON structure. I believe Prince Sunny contributed this. So I use this as a reference. Like I said, this is a pseudo format at this moment. From my understanding is that this is not the final format. It's just as an example. So
yeah,
I use this.
I think this one is just a reference. So I don't think our JSON generation should be based or even looks like this, because we have changed the action types and the names, etc. Like it's not VPC direct, instead it's VNet direct, right? So that example is there in the Sonic HLD document, like towards the end. So I think that format is what I think we should be generating the JSON file.
Yeah, definitely. I mean, these are just name changes. I can just put them in there and format it. And if we go towards the YAML, I can generate the YAML. That's not a problem. I mean, what I have here, it's a Python script that generates a data structure. Data structure can have different names. And then if I use a JSON library to do, Python data structure to JSON, or I do Python data structure to YAML, or whatever format we decide on, yeah, that's, 1-2 lines code change for me. Shouldn't be a problem. And like I said, this is not final. This will morph as the dash config format gets finalized. I will keep doing updates. So if you want me to use those parameters, I'll just change the names based on the other reference example.
Yeah. It's not just about parameters. Like I think we discussed offline that even the IP prefixes are not as a list, so it's like a key, right? So
okay. Yeah. Let me talk about that. So if you take this and you generate with IP prefixes as a list the JSON file for the full hero scale test, it's about 1 to 2 gig JSON file. If you don't make it as a list, and let me show maybe for everyone where it is, what we are talking about. So no, I think it was about the routes. So the routes, because all the routes had same properties. I put them in a list this way. And this file generated for the hero size is like 1.6, 1 point something gig. If I don't put them like this and each route has, other 8 lines of overhead for providing other information, yeah, then it will go to 2 gig. Yeah, it will keep increasing and it become harder for me, to open it and look through it and manage it. So since this was not yet a working sample, I put them as a list. As this becomes working and actually the real DPUs are able to load this config, I will keep morphing it as, as the project progresses, I'm gonna update this generator to be representative of the final config. Now, when it comes to that, yeah, I have a mention here, and this is a request to everyone. There is a mention in one of the files. In normal operation, mapping updates can occur 100 mappings per second or something. Please don't. It's like, think about it. You have 10 million prefixes, 2 million mappings, a million whatever routes, let's say 20 million objects that I need to update on the DPU. At 100 per second, tomorrow you'll still be here looking at how that config is getting loaded. We need tens of thousands, hundreds of thousands of entries being updated every second. We need to set a target for the full scale config, actually, the one with 10 million mappings, 6.4 million routes, and so on. What that should be loaded, and it's not for testing purposes, but when you have like it just goes down. The device went down, crashes, and you have to bring a new device and put it in. How long it will take till the new device gets all the config back up on it? You shouldn't wait.
Think that's the second point, right? Like such cases, it should support scale configuration. So the mappings per second and the ACL or route updates is like once the system is stabilized and it has been like actively carrying traffic and ENIs are enabled, then what you expect is like, consecutive updates. But in the beginning, like that's what like you have to read all the points, right?
Yeah. So this is what I'm saying. Don't take this as also in the beginning. In the beginning needs to be really fast. And at this moment, some implementations are fast, some are not. So I don't know. I think there should be a requirement for how long it should take to get full scale config in here, and it should be, I don't know, seconds or minutes. So we'll have to have a way to push this config to the DPU. Any other questions regarding the config generator?
Yeah. Again. Just simple question. So I'm just trying to understand the whole idea of this generator. So just to understand what is the purpose of it. So as I understand, so it takes the configuration, it generates some different, let's say, like JSON file, and also it is able to generate like kind of different test cases, use cases, to be able to test your device,
the test tool use a config. So the test tool use a config, and this generator ties mostly into the contribution into Git. So for example, we have a test with one IP, one IP, one ACL rule, one ENI, and so on. Here I have, like, let's say the config, it has, I don't know, 100, 200 lines, and you have the config here, uploaded in Git. I don't agree uploading a 2 gig JSON file into Git for the config file for the hero test. So in that case, what I did, I created this generator, which has, I don't know, 100 kilobytes or less, just a few lines of code, which will generate the 2 gig JSON file on your machine. So in Git, we update and we change the logic, maybe the start IP, maybe some counts in the variable files, or maybe the logic here in the implementation, and that generates a config. But we don't have in Git uploaded a 2 gig JSON file in order to be able to run the hero test. You have 100K of Python files that you take it on your machine, you run the generate, and then you upload on your DPU the result.
Okay.
Yeah, so maybe I can phrase it a different way. And think of it as this is an algorithmic configuration generator that can be fed parameters to result in different scale outcomes. And rather than storing verbatim config files, which are gigantic, literally gigantic, the same word, giga, right?
Yeah, huge.
This is an algorithm, and this algorithm can be used to generate literal files like JSON or YAML. They could also be used in principle to drive a configuration API, streaming these configs to a device without ever actually having an intermediate file. You could run these generators and use them to do PSI commands, and we'll be working on those ideas going forward. So that's what this really is. There's months of expertise and experience put into generating these algorithms, tested on real devices. So there's quite a bit of grounding, real world grounding in this. And the only gap that really remains is, do we have an agreed upon canonical format, intermediate representation? If not, we'll just treat this as the de facto one. Thanks.
Yeah, to what Chris said, for example, I can take this, let's say copy paste everything, and then instead of adding, let's say the, ACL group, whatever, to the Python data structure, I can make here the gRPC call that actually creates it when that becomes available, and that will, push the config, generating it here again without having a 2 gig file around. And it's not only about having 1 2 gig files, but I'm sure somebody will ask me, hey, can I have this at a different scale? And then I need to upload, 3 2 gig files because people want different things, or, some IP exchange or some max, or I don't know.
Different test parameters.
Yeah, this way you just change in the variables, you rerun it, and you have your new config up.
Yeah, we will also improve the way the parameters are defined, make it a little more uniform. And then what we could have is a series of profiles that are stored. Those would just be parameter files. And then you feed those into the generator in your development environment or lab. So it'll be a very compact representation.
Yeah, because what I've seen is, we say, oh, we set the scale to this. Oh, well, what happens if we set it to that? Well, what if we set the aging to this or change it to that? And we're trying to change things on the fly, and it's very, very difficult to do it by hand. And I think that's where this came from, right, Mircea?
Coming to by hand, I would not have written a 2 gig file config file by hand in the first place. So this is another, let's call it maybe as a selfish motivation. I had to do this because I did not want to, create such a huge config by hand. I had to write code that will generate the config as a hero test scale.
Yeah.
Yes.
Okay, thanks. Yeah, I understand the whole idea what this gen is doing, but I'm trying to understand who is going to use this generated config.
The test.
So as I understand, so this is tests, right? So it's not okay. So
yeah,
there is
so
a sample
when we talk about this, the test is using the config.
Okay. So you can change easily the parameters and then generate it and then run your test cases based on these configs. Okay, so it's clear.
Yes.
Thanks, Vladimir. Yeah.
And now Chris made a statement. So I'll move also into the test if there are no more questions. The generator is driven by this.
Sorry.
Okay.
I have one question, and maybe you mentioned this, but I'm not sure. Do the parameters for the generator allow you to create prefixes maybe with more like /24s instead of /31s and /32s? Is it flexible enough to like be able to sort of run the hero test with somewhat varying the prefix lengths?
No.
Okay.
Not 24, because 24 assumes 255 IPs, and the max prefixes that we can have right now is 255 or whatever. And if I put basically even the divider to 255, maybe it will create 1/24, but maybe not. So maybe /25 will be the minimum that is currently supported. So specifically, since you said /24, I would say no, but maybe /25 and up are possible at this time.
I guess the point I'm making is like you mentioned, like, oh, maybe there's 6 million prefixes in this hero test. If they're all /31s and 32s, that might produce some performance results. But if they were all say 24s, that might produce a different performance result. It might be useful to have like that kind of flexibility in generating the prefixes.
Yeah, so like I said, 24, I don't think so. Maybe it will work, but I think 25 and up, it will be there.
Okay.
So /25 and up currently. Now, what I have done in my testing while I was doing this, I just went into the, but this requires a bit of code change. You basically go into the route table, and instead of having all this logic here, just have 1/9 route for each ENI, and then your whole routing table gets, one route. And this is how I did it initially when debugging to make sure, let's say I was working on ACLs, I didn't want to have to deal with the routes. So all this logic was stripped down, and it was for each ENI, add one route with ENI IP/9. And that was, avoiding having many routes while debugging. But yeah, currently /25 and up, I would say.
Okay.
Based on, quick napkin math.
Yeah, and the Python code is really pretty readable and straightforward. So you're welcome to experiment. And if you come up with a twist to it or an enhancement that you can, feel like it works well, you can contribute it too.
Mhm.
One challenge which I have here with the values, and this is something that I need to put in the README, it's maybe the max and minimum value supported here, because there are steps like when you move from one ENI to one ENI, the MAC increments by this, and that allows you to have so many IPs and MACs for each ENI. And of course, if you go over that limit, then it will start stepping over the next ENI and so on. So I also had to take into account when scaling this, not to have overlapping and stepping on each other, and also having enough values without running out of them. And since we are supposed to go to 64 and 128 ENIs, basically we increment the first group from the IP, and that will be one from 128 IPs. Maybe if I do it, to 256, I can give 2.2 here. Basically, there are so many IPs in the world. This is for IPv4. Now, once we move to IPv6, and this is when I move into test, yeah, if we do this all over IPv6, then most of these problems are gone IP-wise. Mac, we still have a bit because if I increase this too much, I go into the vendor portion, and it's not a problem having different vendor, let's say, part of the Mac for different TNIs or multiple. I just don't want to run into special Macs where if you have this bit here, set 1, it symbolizes, I don't know, whatever per rules and so on. And this is a flaw of this generator at this time. It does not know to skip special Macs and special IPs. So if somehow currently you put 128 TNIs, it will generate, I think, no, I don't know, maybe 127.0, let's say it will be used, and that's a loopback, and God knows what happens. So this is work for the future. When I scale it past 64 ENIs, to start looking maybe into skipping special IPs and special MACs. That will be something to consider. Okay. I'll move to test. Can you still hear me? It's
Yeah.
Was the answer okay? Or
I think people are digesting the size of this thing.
Yeah, I'll leave it open the PR for a while so people can go through it and give some feedback. All right, when it comes to the test basically it's using the config generated. Why I call it baby hero test, and it's because it's not using all the IPs in the test at this moment. It's just using the first IP out of each ACL rule. So we are using total 48,000 IPs. Where is the dash scale? So basically, the config generated was with one mapped IP per ACL rule and one IP per ACL rule for a total of 48,000 IPs. Now, flows and everything, it's still fine because we are making use of TCP and UDP ports to increase the number of flows. And actually, let me go to the test. So. And by the way, this work is done not only by me, by a team. It's basically Alberto from our team, Vinod, Dinesh portion, me. I think we have Igor here also, Chris, of course. So I'm presenting, but a bunch of people worked on this. Let me go to the test. When we go to test cases, they are all in VNet to VNet. I would ask people to close a bit of a blind eye to this VNet to VNet. Some of them, to me, they qualify more as VPC peering, but for now, we'll keep it here as we are adding more tests. So we have the one IP contributor a while back, and we have the 48K IPs. Till I get to this one, through to our learning, we made a few variations, and all this will be contributed as tests here. So the ones that we presented a few months back was one IP. Now, with one IP, what we noticed, since that creates only one flow, if you have a design where it really encourages parallelism, one flow is not showcasing, the power of the hardware. And actually, this may not be quite the best case scenario for everyone. This may be worst case. And then we increase the number of UDP ports. And here the number should be probably equal with the number of, let's say, compute units that are present in the actual hardware, just to have at least one flow distributed to each compute unit and actually, have your hardware show that it can do. And this becomes a best case scenario. Now, while we try all this, even with one IP and going through the dash test requirements, we figure out that if we put all the source UDP or TCP ports and all destination ports in the traffic, even if we still have one IP, this could create 4 billion unique flows for the DPU. And this is a very simple test that can show aging, can show how many flows you can install every second, as well as how big the flow table is. And also, what if you increase everything till you exceed the flow table size, and after that, you let the flows expire, you come back to a normal amount of flows. And you can see the DPU just had a slowdown in performance because it exceeded the max flow table, and then all the flows get the slow processing. But after that, everything comes to normal and it comes back to the accelerated performance, or it will just crash and end of life for it, and everything will stop working. So this test is very small, but can show a lot of performance and scale metrics of the DPU just by manipulating the source and destination ports. So you can see, like I said, how they expire, how many you can install, flow table size, and so on. And we have a similar test. It makes use also of many TCP ports to create multiple flows in order to be able to do like a CPS test. And this could be also like a benchmark trying to aim for best case scenario. So kind of this was a goal here with the minimum set config, is like if you have minimum config, what's the max the hardware can do? When we come to 48 KIPs, like I said, one IP per each ACL rule. Here, by using multiple TCP ports, we can actually, or UDP ports, we can do the full scale in terms of flows required in the hero test. Let me see if I still have it on one of the screens. Second. No, back to the hero test. So what we are doing, we are maintaining the full, here, 6 million flows. So you have 6 million parallel flows in the test. And while we are sustaining 6 million parallel flows, it does not have the TCP and UDP mixed in together. At this moment, they are separate. I'm working on mixing it together. So it's only TCP, 6 million flows all together. And at that point, we are measuring the CPS. Now, there are a few considerants and changes from here. This talks about six packets. It's not 6 packets. One, we are making use of HTTP traffic to do actually the TCP use case. So you have the 6 packets from TCP plus the get and the response from HTTP. That's 8 packets. Plus, you have to consider that if you maintain 6 million flows active, so you have in the table, but the CPS of the device is, I don't know, let's take a random number, 2 million. Okay, 2 million flows per second. It's what you can install. Then that means every flow will live for 3 seconds. That means you need to send an extra keep alive packet. Otherwise, your flow will die because of the 1 second flow timer. So when you consider the 6 packets from here plus the 2 from HTTP plus the keep alive, if the performance of the DPU does not exceed 6 million CPS, then this becomes more like 8 to 10 packets per second. So here where it says effective PPS sustain, it's not quite this. Like I said, this is multiplied by 8 or 6, depending on the cases. So this is something to consider. And at this moment, yeah, I didn't find a way around it. I can reduce the number of packets, but it will reduce some of the TCP packets actually. And I still need the HTTP packets for the application on top of TCP for traffic. And if you need the keep alive, you need the keep alive. I mean, there's nothing I can do about that. Otherwise, the flow will go down. So this is regarding the scale and packets and so on. Now let's go back to the test cases.
Mircea, I have
Yes.
a couple questions about what you're saying here.
Yes.
The flow won't time out if those packets are all sent within the timeout window, right?
Yeah.
So I'm not sure I'm understanding why there's like a keep alive needed. And also, I'm concerned about the 8 packets versus the 6. I mean, that like effectively will reduce the connection per second rate that's reported for a given DPU.
Okay. I mean, I understand this, but
So
you
first,
need
the
some
keep alive.
data over the TCP.
First, explain the keep alive.
Yes. So we have 6 million flows which are active in the DPU, correct? And your CPS or flow install rate, let's say it's 2 million, yeah, for your hardware. That means you can install 2 million flows every second, but you need to have 6 million parallel flows. So first second you install 2 million, second you have 4 million in the table, but in order to have 4 million in the table, the first 2 million flows that you install a second ago, you need to send the keep alive on those flows, because otherwise the second has passed and they will be age out and they will disappear from your flow table. So you will not have 4 million in the second. And then third second, you install another 2 million flows. The flows from a second ago, you need to send a keep alive to keep them, and also on the flows from 2 seconds ago in order to reach 6 million flows in the table.
I hear what you're saying. Maybe it's not my understanding. I thought that there would be background flows that would like occupy the table, and those background flows will have keep alives. And then like the active flows like don't require keep alives. They just send their 6 packets like within the timeout.
Okay, fine. You have the background ones, yeah?
Yes.
Okay, let's take them out.
Those are static. Those are like static. They're not like, you know.
Perfect. Okay.
Okay.
5 million. Okay. 5 million. Your CPS is still 2 million. Okay. 2 million first second, 4 million second. You are still not at 5 million flows in the table. You still need to send the keep alive. As long as your CPS does not exceed this number, you need to send the keep alive. Whatever this number, if it's 5, 6, 3, whatever the number is, I'm just saying as long as, let's say this number is 1 million. Okay, if your CPS is 800K only, you need to send the keep alive in order to achieve these flows in the table. As long as
I guess I'm questioning whether that's the correct way to do this. Like if you want to guarantee that there's always 5 million flows in the table, then there should be 5 million background flows that have keep alives and they stay in the table.
But then you don't measure CPS.
No, and then on top of that, you measure CPS, but the flows that are measuring CPS can be very short-lived. They don't need any keep alive. They're just very short-lived.
But if the required number of flows in the table, it is higher than your hardware ability, you will have the flow need to live more than a second, which makes it needs a keep alive. There is no way around it. And then if you put here 5 million background flows, that changes the test. You need 5 million background flow sending packets plus the CPS. So now you become I don't know, let's say the DPU, like I said, 2 million, and you have 5 plus 2, the CPS, and becomes like 7. That changes in a way the test numbers. But as long as your CPS is lower than this number, you need to keep alive.
I wonder if we could have a separate conversation about this, because it sounds like it could take a bit to go over.
Yeah.
What do you think, John and Mircea?
Yeah, I can set a different meeting about it, but
yeah.
I mean, if there is a way, I'm welcoming it. Okay.
Yeah, me too.
Don't. It's just I personally have not found one around it.
I mean, I know you don't want this to drag out, but I'll just make one statement. I think it would be better to not have the keep alive and instead like have an API or something where the data plane can report how many flows are like active in the table. And so then, like, that's just part of the measurement of the test. If someone's running at low connection per second rate, you can see that. But like, I think that the connection per second flows should just be short-lived, like shorter than the timeout.
Yeah. So we have done that, and is the other option, or what I can do. Okay. I don't care about the flow table size. I completely ignore this line.
Yes.
And I just send the packets as fast as possible, where basically it brings up the TCP session, it sends the data, and the moment the data got received, the fins are sent,
Yes.
and the flow is out of the table. But when we run the test that way, and I go on the DPU, and I ask the DPU, hey, what's your flow table size? It just come and say, oh, I have 10K flows per hour, or I have 100K flows per hour, which is far from the number required here. So that was my problem, and this is why I put this constraint in the test, because if I do it as fast as possible, the actual flow table on the DPU, it's almost empty. I mean, it has a requirement of 64 million flows, and you have 10K flows reported by it as parallel.
Well, it shouldn't be empty. It should be the size of your background flows.
Yeah, I mean,
yeah. Okay.
I'm not talking about background. I'm talking about the active ones.
Okay.
So this
fine.
is a point for research, I guess, because
yeah,
we have some of the smartest people in the world on this call. So,
but just to this for me, this was not 6 packets, was more, and I had this thing. So this is why I'm bringing it here. So,
So yeah, let's explore that further. If anyone wants to volunteer to
go, so I'll quickly just close.
I was just gonna say that if anyone wants to go over that further and more fully, and has a strong opinion on this kind of stuff, let us know, and we can cover it. Go ahead, Mircea.
Yeah, so with UDP traffic, usually what we see, it's more like a conformance. We are sending traffic also on denied IPs as well, and we see if actually those are being dropped 100% and nothing goes through, and making sure ACL are being respected. Also, if sending traffic over the denied IPs has any impact on performance. The TCP and the hero test sends traffic only over the allowed IPs. So that's something important to note. And few things. So all this will be contributed in the next few days. The script at this moment, the one in the PR, it is the TCP 48K IP is this one, the baby hero test, as we call it, since it's not the full scale. And few other tests, this will come in the next weeks, months. We still need to put the TCP and UDP in the same traffic at the same time. Contribute the full hero test, like generator, it's already doing the full hero test and so on. I just need to run it, validate it, and finish from my side before I upload it. Then do everything that we did here with IPv6, and then do another one, which will be probably a hero test, which will have a mix of IPv4, IPv6. Here I have to see the support on this. If it's IPv6 over IPv4, IPv4 over IPv6, IPv6, all the combinations what are supported by Dash, and try this. So this is regarding the test. And the whole purpose of this, the way I see it, maybe not stated in the hero test, but the way I saw it, is that if I am able with this test to show the best the device can do ever, as well as the worst a device can do ever. And by the way, different hardware implementation different tests will be best or worst. That means the production performance will be somewhere in between min and max. Somewhere. So if your best is, I don't know, 3 million and your worst is 1 million, then it's like in production, you'll get between 1 and 3 in real deployment. Kind of that's the idea. We did all these variations and tests. This is why we have multiple and not just one.
Yeah. So if anyone's passionate about testing, please sync up with Mircea and Chris and collaborate there, because this is awesome, Mircea. Thank you.
Yeah. One thing that we are working on, and it started, it's already partially contribute in this, is latency measurements. I'm not sure if they are necessarily specified in the hero test, but also we are looking at TCP kind of application latency as well as packet in, packet out latency. And for that, I will make a PR, in the next few weeks about how you test it. Because for latency, what you want to do is basically take the DPU out, put a cable, like a 1 meter cable, runs the test. And by the way, since DPU is supposed to be a bump in the wire, most of these tests will run like that with very small changes, and I'll have to document those. Get the latency numbers for the whole test setup, and then put the DPU, run the test again, get the latency numbers, and subtract, and basically that's the latency added by the DPU per packet or per application. So that's something that's coming. I think application latency, we are showing it as of today, but I need also packet in, packet out latency, and to document more how to execute the test, because the testbed has an intrinsic latency that you need to subtract from the DPU latency.
Mm-hmm.
Okay, that's all. I'll leave the PRs open for a week or what's needed, just so people can give feedback.
This is amazing, Mircea. Thank you so much. Yeah, everyone, please take a look if you can. And I think we should have more of a conversation on the Keep Alive discussion, et cetera. We'll figure out how to talk about it. And if we can't do it in the next 7 days offline outside of this meeting, then maybe we could pick it up in the next meeting. I'll try and figure it out. So please keep thinking about it in the next 7 days. And I had an oversight at the beginning of the meeting. I forgot to introduce Pranjal. So Pranjal's on the call, and he's a principal software engineer and works alongside of Michael Zygmunt, and he's joining the project. And so Pranjal, if you could say hi to everyone. On the call, we have multitude of people in the industry, some of the brightest people from Keysight Labs, Broadcom, Keysight, Intel, NVIDIA, Pensando AMD, Dream Big Semiconductor, everybody. So if you could just say hi.
Hello everyone, I'm Pranjal. As Christina introduced me, I'm working VNet team, and it's great to be here, and I'm looking forward to learn more about Dash, hopefully contribute. This is my first meeting for me. I mean, takeaways. I'll go back and look over the recordings and get in pace with whatever is
and
going.
I can work with you hand in hand, and we also have Intel, and we have Broadcom, and just everybody. And so this is more like Michael's peer. So good to have him on the team. And so normally what we do, Pranjal, is I close the meeting recording and post it to YouTube and send meeting notes by Friday, unless I do it on Saturday. So is there anything else, rest of the team?
Hey, welcome, Pranjal.
Welcome, Pranjal.
Yeah, nice to meet you.
Thank you, everyone.
Great. Mircea, again, thank you so much. That was awesome.
Thank you.
Okay, I'm going to stop the recording, guys, and give you 4 minutes back. And
if we can please paste the PR, Mircea's PR in the chat, that would be great.